Hello, welcome back to class. Today's lesson is going to be on chapter 5-5, which is standard and point slope form. And so to continue our umbrella analogy from the last lesson, if we have an umbrella and that umbrella is linear equations, one of those linear equations is something that we've learned about. That's y equals mx plus b, and that is your slope-intercept form. That one we covered in the last chapter, and that's the one we've been dealing with a lot. The next one is going to be ax plus bx, or plus by, equals c. And so what you might see in here is that there's no m or b, so no letters that will tell you what your slope is or what your y-intercept is. So we're doing something completely different with ax plus by equals c. The most important purpose of standard form is how it's used to find two important points, which are points, if this is your axes of a graph, wherever the graph hits the y-axis and wherever the graph hits the x-axis. With the standard form, we can find those 2 points, and if you know those 2 points, you can map the graph out. Alright, now I'm going to explain to you what the different parts of the standard form equation are, and then we're going to learn how to use the standard form equation through this here snowman. We'll call him Sam, Snowy Sam. So Snowy Sam is pointing over here with his right arm because he wants us first to work on the standard form equation. Snowy Sam wants to know, what does A and B and C mean in this equation? There is no M or B, lowercase b, so we don't know slope or y-intercept, but these mean something. What these mean are that in front of the x, the y, and the y, there's numbers there. Even if it's just y, there's always a number in front of the variable. So in this case, if there's just a y, the number would be 1. However, if we had an equation like this, 3x plus 2y equals 5, then a, b, and c are the numbers we see in front of the variables, and then c is the constant after the equal sign. So a is 3, b is 2, c is 5. However, not all equations are already in standard form like that one. Suppose that you have an equation that looks like the ones that we normally do. Y equals 3x plus 2. What you have to be able to see is you have to be able to see that y and x in standard form have to be on the same side of the equation. So we want to take this 3x and we want to bring it over here. And to do so, we have to subtract 3x's from each side. And that'll leave us with negative 3x plus y equals 2. In this equation, our a, which is next to the x, is negative 3. Our b, which is next to the y, would be the invisible 1. And our c is the 2 after the equal sign. So with all the equations that you'll be dealing with, whenever they want it in standard form, you have to be able to change around the equation until you have variable with a number in front of it, variable with a number in front of it equals a number. Alright, so how are we going to use the standard form equation? What's its purpose? And so there's 3 levels to this. To find its purpose, we first need to be able to take an equation and turn it into standard form. And so let's use an example here. Let's say we took an equation, we turned it into standard form. That standard form was 2x plus 3y equals 18. All right. Now, the first purpose, this purpose right here, this section of our snowman, is we want to figure out what the y-intercept is. The second purpose, this spot right here, we want to figure out what the x-intercept is. And if we're able to do that, if we're able to find a point on both the x and the y axis, then we'll be able to graph our line. So to find the y-intercept in standard form, the way you do that is you put x equal to 0. When you put x equal to 0, what that's saying is you're looking for a point on the line where x equals 0, so right along here. And that point would be somewhere along your y-axis. So to find the y-intercept, you're looking for where x equals 0. And maybe this will also help you if you don't understand that. Any point we find along this line, any point along here, is always going to have a coordinate pair where the x is 0, and then the y will be some number, which we would plug in right there. So if the x is 0, we have to put a 0 in right there. So back over here, 2 times 0 is 0, so we're left with the equation 3y equals 18. If 3y equals 18, then to find what y equals, you divide each side by 3, so therefore y equals 6. Y equals 6. And so over here on the graph, you would plot where x equals 0, y equals 6, and we'll say it's right about here. Alright, so now to find the x-intercept. And what the x-intercept is going to be is the point where the line hits the x-axis. And similar to up here, we have to find the x-axis by putting a 0 in for y. So we have 2x plus 3 times 0 equals 18. Alright, and so when the y equals 0, that means the y is going to be right along here, somewhere along there. So any point we find along here is going to have a coordinate pair of x is some number, comma, and then y is 0. So in this case, if y is 0, what does x equal? 3 times 0 is 0, so we erase that. So 2x equals 18. How do we find what x equals? We divide each side by 2. And 18 divided by 2 is x equals 9. Alright, so we have our x-intercept and our y-intercept. X-intercept is where x equals 9, and we'll say it's somewhere out here. This is our x-intercept, 0.90. And so our line for this graph connects those 2 points. And there you have it. That's how you use your standard form.